This quarter we decided to take a different approach when creating our design notebook. We made a Google website. Highlighted here are our interface specifications. We believe that they are a good summary of our end goals for the AquaROV. And we would like to create a wirelessly controlled submarine capable of full three-dimensional movement throughout an aquarium. In other words, we would like to design both a wireless remote control and a wireless toy submarine. The end user will be able to take the toy submarine, place it inside of his aquarium, and wirelessly control its movement via a remote control. Other features of our website include subpages for the assignments we completed this quarter, including the market survey and the feedback review, a subpage for noting our progress, which includes a section on our group meetings where we put how much time we spent in each meeting and what we accomplished during each of those meeting times, as well as individual time spent on the project. We also have a sub-page for the designs we completed this quarter. This quarter we only completed the electrical hardware, which includes the schematic design. The schematic design modules we completed include a 27 MHz transceiver, a 3.3 volt power supply, and a USB lithium polymer battery charging circuit. We have a subpage for all of the components we have purchased and the total cost of all of those parts. And that is the AquaROV website. Here we are testing our H-bridge motor drive circuitry. Let's turn it on. Right now the motor is in the idle state, which in our circuitry will pertain to a logic level of 0, 0. If we give it a logic level of 1, 0, the motor rotates clockwise. If we give our motor drive circuitry logic level of 0, 1, the motor should drive counterclockwise. And if we give our motor drive circuitry logic level 0 or 1, 1, the motor effectively brakes. Okay, we're going to test the typical current and max current of our motor drive circuitry. So right now the motor's driving clockwise, and we're going to see how much current the circuitry is pulling, and that's around 10 milliamps. Now we're going to reverse it and do counterclockwise. It's pulling 8 or 9 milliamps. And finally we're going to test the max current or the stall current of our motor, which is around 19 milliamps.
Our MSP430 demo board that Kevin's been working on putting some code in just to try and make sure everything works. And in the code that's currently loaded in it, when you press the button, the light lights up. Same premise would be used in our submarine, except when we press the button, it sends a signal to the MSP430, which will turn on a logic high, which would go to the motor circuit that we have already built and tested, and we show in a separate video. So it's the same premise, just we would be hooking it up to our other circuit instead of a light. This is our current aspirations for an enclosure for our submarine. This once upon a time used to be a chapstick container. As you can see, it's kind of a small area in there, but we hope to be able to fit everything in there by designing and getting produced actual boards to solder everything onto to keep everything really small. We have found that this might be just slightly too small because of battery size that we have ordered currently. So we might have to change this, but this is our current hopes to be able to have something this small.